Hi, this is Jeremy Jansen, and I'd like to welcome you to the April 2010 issue of Reason Wizardry. This month we're going to be talking about wave sequencing in Reason. In case you don't already know, wave sequencing is a synthesis form that's been made popular by a number of different hardware and software synths. Definitely the main one is the Korg Wave Station. This was huge in the 90s, used in a massive variety of movies and TV shows. I remember it always specifically in the amazing X-Files soundtracks. And then moving to software synths, lately there's been Steinberg X-Phrase, which also did wave sequencing, and our own Nucleus Sound Lab Viral Outbreak VST instrument specializes in wave sequencing as well. What wave sequencing basically is crossfading between various samples in series in a rhythmic way. So this isn't something that's really simple to do in Reason. The way Reason is set up with NNXT samplers, there's not a straightforward way to accomplish something like this. So I'm going to show you a very complex technique to create a wave station, wave sequencer-like instrument. The first thing we need to do is establish what exactly wave sequencing is. So to do that, I've loaded up 4 NNXT samplers with different patches in them and run them through a mixer. So let's hear them all at once. And then one by one, we've got the bell pad, the violins, Trinity voices, and the tamper texture. Okay, so what we want to do is smoothly fade between each patch in series. So I'll show you what that kind of looks like by manually automating the mixer here. So I'll play a chord. Okay, so something like that. So to do that, we're going to need to crossfade between all these 4 sounds and automate that crossfade. And somehow we're going to also have to make it playable polyphonically as a chord or as faster notes and make the wave sequencing as flexible as possible. The first thing to get out of the way is that there's a limitation to this technique, and that is that even though once we're finished we'll be able to play it polyphonically, we're not going to actually have polyphonic sequences, and that's an important distinction. What that means is that unlike the wave station or viral outbreak, we're not going to have a different sequence for each note that we hold down. So what are our options for crossfading between these patches and automating that? Obviously, we could leave things set up like this and try to automate the mixer channels. But what we'd be getting then is a linear crossfade. And if you watched one of our earlier episodes, I discussed the difference between a linear and equal power crossfade. Linear isn't going to sound good. So we need to use equal power crossfades, and I've also discussed that, how to do it, in a previous issue. I'm going to also link here to a Propeller Heads article in case you need a bit of a refresher. But we're going to just delete the mixer and get on with creating some equal power crossfades. So how many crossfades do we need? We need one crossfade between sound 1 and 2, one crossfade between sound 2 and 3, and one crossfade between sound 3 and 4. So we need 3 crossfades. And if you remember from our equal power crossfade tutorial, you require 2 line mixers for each crossfade. So we need a total of 6 line mixers. Okay, that's quite a mess. I'm going to add 3 equalizers here, minimize them, and just set them in here so that our banks of crossfaders are kind of separated and more legible to the eye. All right, so how's this going to work? Let's start some audio routing. Okay, so we got some routing here, auto set up. I'm going to just get rid of all of it. Okay, I think we're good. So to start with, we're going to route the bell pad down here. And we're going to be crossfading that with the second sound. All right, and we're going to take that output and send that as the first source for the next crossfader. And so now sound 2 is going to be crossfaded with sound 3. And again, we're going to go the output from this crossfader. I've made a small mistake here. Of course, when making crossfaders, you have to use the left output from both line mixers. There we go. Do that right this time. So the output from our second crossfader is going to be crossfaded with the fourth sound. And our output is going to be sent to the combinator outputs. All right, that kind of looks artistic in a way, doesn't it? I'd prefer to be working with it minimized myself. Now we're going to set up the crossfades in the combinator programmer. So the technique I'm going to show you here is the way we've talked about it before. We're going to be using the 3 combinator knobs to control the crossfade. We could also be doing this just purely using CV signals, and you'd want to do that so that you could save your combinator rotaries for a different use. But this way, we're going to be able to see some of the controls in motion. We'll be able to visualize our crossfade, which just makes the whole thing a little bit easier. So we're going to use that slightly less flexible technique, but easier to understand for this tutorial. All right, so we'll go in here and we'll start with rotary 1. We're going to map that to channel 1 panning. And then, of course, the opposite for channel 2 panning, rather. Okay, same thing here. So we've got our first crossfade set up. All right, we'll go to our next bank of line mixers and we'll use rotary 2. Remember, if you have trouble with this, head over to that propeller heads link that I provided earlier in the issue. It's pretty straightforward stuff. All right, so we should be able to name this now, crossfade. Now our final crossfade, we're going to be using rotary 3. Now we should be able to test out and make sure the crossfades are working. So let's play a note here. There we go. We have to turn the volume down on the last bank of crossfaders just because each time we're running it through another bank, it's actually increasing the volume. So I'm going to turn these down to 55 each. All right. So now with all the crossfade knobs set to 0, we just hear sound 1. And then we have sound 2. There we have sound 3, but it sounds like we've made a mistake with one of our connections. Let's see what we've got here. There we go. There we go. And now we'll hear sound 4. Okay, so you can probably see where we're going with this. Now we're going to use combinator modulations to automate when the crossfades happen. Now we're going to add some Thors that are going to process some CV and automate our crossfades. So we're going to need to add 3 Thors because of course we have 3 banks of crossfaders. All right, so we've got the 3 Thors. We're going to take their modulation output, CV1, and send it to each combinator rotary. Let's minimize some of this. All right, so the first Thor is heading to rotary 1. Second Thor to rotary 2. Third Thor to rotary 3. Okay, now let's open up the Thor. Get rid of some unnecessary stuff. All right, so there's a whole variety of ways we could try to use Thor to automate this combinator rotary. Now, the first one that came to mind to me is the global envelope. And that's because you can use the loop mode of the global envelope and sync it. And then you can set each stage in a musical value. So you could have an exact amount of time that each knob will be held for before it will fade back down. And that's what we want when we're going to be automating the crossfades. The problem with that technique I discovered is, of course, we won't want all the global envelopes to be starting at the exact same time, because the second crossfader, we only want it happening after the first crossfade has happened. They need to happen in sequence. So I thought that perhaps we could use the delay parameter for that. But the delay is actually part of the loop, so it's just not possible to get proper timing this way. So I developed a different technique that also uses the global envelope, but it's going to use the Thor step sequencer as well. So the first thing we need to do is route the global envelope out CV output 1 at 100. All right, so now we're going to set up the global envelope. We're going to turn off loop. We're going to keep tempo sync on. Delay is going to be off. So attack is going to determine the amount of time that it takes for this knob to reach full. So for now, we're going to leave it at 1/16. We're going to put hold all the way up. We're going to put decay also at 1/16. We're going to put sustain all the way up. And we're going to put release at 1/16. Now let's see what we get. This is our first bank of crossfaders, and the crossfade happens by automating the pan knobs. So keep your eye on the pan knobs here. Okay, so we've got a very quick crossfade happening there. And it's not looping in any kind of sequence. So we're not going to worry about the loop right now. We're going to set up our other Thors exactly the same way. So actually, I'm going to save some time here and just duplicate this Thor twice. And delete these two extras. Now I'll just need to redo these CVs up to the combinator rotaries. Okay, just a little shortcut there. So now they're going to all happen at once. They should all happen at once. Okay, so they're all working, but it's not happening in sequence, and it's not happening in a loop. So we've got everything set up, but the timing of when each crossfade should happen. And that's what we're going to do next using the Thor step sequencer. We're now working on setting up the Thor step sequencers to control when the crossfades happen in our Wavesequencer. So I've already got this step sequencer set to repeat mode, and I've got it set to 8 steps. All right, so now in our mod matrix, we want to set up MIDI key gate, going to step sequencer trigger. That's going to mean that every time we push a MIDI key, our step sequencer is going to start. Just like that. Okay, and now we want the step sequencer gate to trigger our global envelope gate. So now we need to consider how that's going to work. So by setting up gate signals here in the sequencer, we can determine when the global envelope is going to be triggered and when our crossfade is therefore going to happen. So I've got 8 steps here. So the first step, nothing actually needs to happen. We don't want a crossfade happening because it's going to play our bell pad. Without any crossfades happening, we just get our bell pad, right? Well, we've got some other crossfades set up, but ideally, the first step is going to just have the bell pad on it. So here is where we want the first crossfade to happen, and that's the crossfade that fades between bell pad and the violins. I'm going to quickly disable the other crossfades so that we can hear the first one in action. Okay, now okay, we also need to set the gate length to full. That means that this is considered as one gate signal instead of two, one sustained gate signal. We actually have to set a longer gate signal because what we want is for that crossfade to happen and stay there until right before the sequence loops again. So we actually want that held. We want this crossfade held longer. We'll say like that, 4 steps. And we'll adjust the gate length so it's considered one long step. Now let's have a look. Okay, that looks good. What I'm going to do is duplicate this once again and delete our 2 extras. And reroute our CV signals. All right, so now all we should have to do is adjust which steps we want. So for the crossfade in the second bank, we want that starting here. And we want it to be 4 steps as well. So we'll adjust the gate length. And for the final crossfade, we want it starting here. And we shouldn't need to make it 4 steps long. Now let's watch all 3 banks of pan knobs move in sequence. You'll see first these knobs, then the second group, then the third. Okay, so there we have the basics set up for our crossfader, and our Wavesequencer is really shaping up. So next we're going to add some very useful parameters and tweaks to round out the functionality of our Wavesequencer. The first change we need to make to our Wavesequencer is a way to adjust the amount of crossfade. Right now it's very quick. Those pan knobs are moving so fast that it's not really giving a smooth fade between the 2 sounds. So that smooth fade comes from the global envelope, attack, that's the first initial movement, and then release after the crossfade happens, how long it takes for the rotary to go back to its 0 position. So we're going to set up a modulation in our combinator that's going to control all 3 Thors, attack and release. So let's get in here, and we're going to actually use the mod wheel for this, because we're kind of short on rotaries here. We've got 1 extra, but I want to use that for something else. So we're going to use the mod wheel. So you got to go way down to find the global envelope attack. Global envelope release. So I've already kind of found some optimal settings for this. It's somewhat tough to describe exactly why they should be set to these values. You're welcome to tweak and see if you can find something perhaps more suitable, but we're going to start with these 20 and 100, and 90 and 127. So we need to duplicate that for our other 2 Thors. All right, one more. All right, there we go. So let's hear what that sounds like and watch what it looks like as I adjust that, and the pan knobs will move in a different way. So without touching the mod wheel, we'll just hit a note. Now I'm going to slowly move the mod wheel up here. So that's back with it down all the way again. So depending on how fast the sequence you have, you may want to use a different mod wheel setting. Obviously, with a slower, longer wave sequence, you're going to want it to be smoother, so you're going to have the mod wheel up higher. With a faster, more rhythmic wave sequence, you're going to want the mod wheel lower. So you just kind of have to tweak depending on the speed of your wave sequence. It's not automatic, unfortunately. So now, speaking of wave sequence speed, that's what we're going to be using our final rotary for. So we're going to also do that by setting up some programming in the combinator for each Thor device. And we're going to use rotary 4. So we're going to open up the programmer here, go way down again, and find 16-step sequencer synced rate. All right, we'll just leave that as is and do the same thing on Thor 2. And Thor 3. Okay, so now let's reset that, and we'll hear our sequence change in speed. So you can see right here our sequence is set to 3/8, which is kind of odd actually. There we have it set to half bar steps. So with a longer sequence like this, we're going to want to use a higher mod wheel setting. So let's turn that up. And once again, you can watch here. So I'll start it over again and we'll just point out the different sounds as they appear. So we start with sound 1, sound 2 crossfades, sound 3 crossfades, sound 4 crossfades, back to sound 1, and sound 2. We're going to continue on making some usability changes to our Wavesequencer. The first thing I want to point out is that while I've been working on this, I've actually found some more optimal global envelope release values. So I've actually ended up saving the patch with those values in case you're wondering why those are different than the values I gave you in the previous chapter. It's just because I found something that worked a little bit better. And also I've modified the fourth sound to brass grains. I didn't find that the other sound worked very well with chords, polyphonic sounds, and since that's what we're going to be kind of focusing on next, I thought it was a good idea to change it to something more suitable. Okay, so I have one of the Thors already open here, and we're going to examine what happens when we play multiple notes using the Wavesequencer. So I'm going to hold one note down, and then I'm going to hit another one. So the wave sequence continues playing after I've hit a second note, but if I let either key up, the sequence stops. So if I'd hold one note and then hit another note multiple times, you can see that the wave sequence never really gets started. It continually resets itself every time we let off a MIDI key. I don't really like that from a playability standpoint. I'm looking for something a little bit better than that. So I've kind of researched a way that we can move past that. So the first thing we need to do is change this MIDI gate to voice key gate. Now, we've talked before about the difference between voice level parameters and global parameters. And basically everything above this line right here is a voice level parameter, and that means it's considered polyphonic. So even though we can't have polyphonic sequences, like I said before, we can still have our sequences respond better to polyphonic notes by not resetting our sequence every time we let our finger off a key. So that's the first change we need to make. And the second one is we need to go mono legato. Now let's make this change on all three Thors. All right, now let's test this out. Let's hold down one key and play another key repeatedly. Okay, we've got one more small change we need to make. That actually worked fine until the sequence looped. And that's because I've forgotten to turn off the step sequencer trigger up here. Let's try that again. So now we can play whatever we want. The sequence continues starting from the first note held. So as soon as we press the first key, hopefully we're in time with our sequencer or whatever we're playing along with, everything is going to continue on that same sequence. Every note that we hit, until we let go of all the keys. Now our wave sequence pad is pretty much complete. Let's just hear how it sounds with a little bit of multi-tap delay. And let's try it with an arpeggiator. Perhaps I'll slow that down a little bit. Let's give that a shot. I think that's a really impressive sound, created purely out of the Reason environment and some sounds from the Reason factory library. Of course, using third-party sounds, you can expand your palette for wave sequences, or just using other sounds from the factory library. And just to give you a quick example of that, I've got an alternative patch here with just some different samples selected. So I'll just show you here. I've got the Resonic pad, organ, J60 logos, and the Mellotron choir. And let's just hear what that sounds like. So that's pretty unlike the sounds that you can usually come up with using Maelstrom or Thor. This is definitely something off the beaten path, but it's a really useful sound that, of course, was extensively used throughout the 90s in film and game soundtracks, and it still sounds very unique. Personally, it's one of my favorite synthesis forms, as you might guess, by our creation of the Viral Outbreak VST. Anyway, I might play with that for a while, so I'm going to just leave it there. You've got a series of wave sequencer patches to work from. You can start right from the beginning, or just work right from the final product in part 5 and take it even farther than we've already gone. So I hope you found the April 2010 issue of Reason Wizardry really useful, and I love feedback on it. If you made some wave sequence patches you'd like to show off, definitely send them over, and I'd be happy to give you feedback. All right, this is Jeremy Jansen, and until next month, cheers.